Hi, Geometry. I know some of you are struggling, but some of you are zooming ahead. So I'm going to do this video. I'm going to try to do each lesson's video for you. So it's just like I'm teaching. And then don't forget, if you have a question, just text me the question. Say 12.3, number 21. And I will get back to you. I have my little whiteboard and I can start working it out for you. If you don't have a cell phone, you could say to your parents, I'm going to be working on geometry from 9 to 10. Can you please loan me your cell phone? That's the quickest way because I don't check my email immediately. I don't get notifications of email on my phone. So I don't check my email every second, but a text will get my attention right away. So that's the best way to do it. Keep sending it by email if you have to, but please let me know that you've gotten my answer and that it's helped out. I'm here to teach you, and even though we can't be face to face, I have helped several of you by text, and it seems to be working pretty well. So please continue to do that. Don't bother your parents. They already have too much to do. They don't need to learn trigonometry on top of everything else. So please text me. Thank you. All right. First of all, if they ask you to put a vector in standard position, all they're asking you to do is move it so that its tail is on 0, 0. So a vector, if they give you a vector way over here, just move it to there. But you make it the same direction, the same angle. You just move it there. So that's just one little tidbit that's in your book that you might have missed. Now, they want you to draw this vector. This is what's called component form. And look, it's XY form. So basically, plot that point. 2 on the x-axis, -3 on the y. So 2, -3, and then the tail is always on 0, and the point of the arrow will be on that dot. So that's your vector. Now the direction is you usually want the direction from the x-axis. So this angle right here would be theta. So draw yourself your representative triangle. This side of the triangle would be 3 and this side would be 2. Okay, so that opens up all kinds of possibilities. If they ask you for the direction, they want the angle, and then they want you to say south of east or north of west, west of north or something like that. So the angle can be gotten using trigonometry, which is what we've learned. All trigonometry is ratios in right triangles. So the sine is the ratio of the opposite side over the hypotenuse. The cosine is the ratio of the adjacent side over the hypotenuse. And the tangent is the opposite side over the adjacent side. And you can use these relationships to solve because the sine of a 30-degree angle is always 0.5, no matter how big you draw that triangle or what the sides are. So you can always solve using that. Your calculator has all the sines, cosines, and tangents stored in it. In the old days, back when I first started teaching, you had to look in the back of your book for a table of sine, cosines, and tangents. So count yourselves blessed. So you've drawn this, and now if they want the magnitude and direction of this vector, magnitude always means the hypotenuse. So you guys should know that the Pythagorean theorem is easily done. That gets you the magnitude. So magnitude, get by the Pythagorean theorem. So you would say 2 squared plus 3 squared equals the magnitude squared. So 4 plus 9 equals the magnitude squared. So the magnitude equals the square root of 13, which you can leave it like that. Okay, magnitude is the square root of 13. That's how long this is. Now for the angle, well, we have the side adjacent to the angle, and we have the side opposite the angle. So the side adjacent is 2, the side opposite is 3. So if you remember SOHCAHTOA, tangent has opposite and adjacent. So you would say the tangent of this angle is opposite over adjacent. Now this is where you have to use your calculator because we don't have books with the tables in the back anymore. all you have to do is hit the second button and hit the tangent button, and it'll come up with a display that looks like this. Then you just put in what the tangent is, because what this means is the angle whose tangent is 3/2. And when you punch that in, if you're set on degrees, you will get the answer. Okay, I don't know if you can see. Second, let's turn this on. Second tangent, and there's the display. I don't know if you can see it from there, but then you punch in 3/2, and you get 56.31 degrees. So 56.31 degrees. So your answer would be this vector. This is always east. Just think of a compass. This is always north. This is always west. This is always south. So this is south of east. So your answer would be it's root of 13, and it is 56.31 degrees south of east. And that's how you would write your answer for that. So you see how we're using our sine, cosine, and tangent to find our direction for our vector. Now, we use vectors a lot in science, especially in physics. So velocity is something that's always written as a vector, because velocity is a speed with a direction. So in this, they give you something is going 20 degrees west of south, 36 knots. So here is east, north, west, and south. So if it's going west of south, here's south, and it's going to the west of south, so it would be 20 degrees right there, okay? And the magnitude is 36 knots. So that would be our vector. Now, if we want to find the components of that vector, then we would just use sine and cosine. So the sine of 20 degrees equals our cosine would be, our sine would be x over 36, opposite over hypotenuse. The cosine of 20 degrees gives you our y component, because this is the cosine. So the main thing is you have to draw these pictures. I don't know where you're getting your answers from if you don't draw these pictures. I don't like to assume that you're just copying out of the book, but I can't do this problem if I don't draw the pictures. So draw the pictures. I want to see x, y axis. I want to see these, especially on the test. So you have to draw the picture to set up your triangle so you can see what you're using to get your x and y, your sine and cosine. So x is going to equal sine of 20 times 36. And y is going to equal the cosine of 20 times 36. Don't leave it like that. You got a calculator, get the answer. Get numerical answers, you're going to get decimals. So that's what this means when you want to plot that. Now, adding components. Well, when they say components, they just mean the x, y, and this is actually probably one of the simplest things about this. If I have vector u is 2, -4. Vector v is 1, -3. So I want to do 1/2 u minus v. So basically I just say 1/2 2, -4 minus 1, -3. Now let's distribute the 1/2. So we now have 1, -2. And let's distribute this plus -1, 3. Then you just add your x's. 1 plus -1 is 0. -2 and 3 is 1. So our resultant vector components are 0, 1. And so 0 on the x-axis, 1 on the y-axis. So you can see this is the magnitude of this is just 1 at 90 degrees, or 1 due north. Okay? Now, this one is tricky. There's one on your homework like this. A couple of them on your homework are tricky. But if you draw them, use sine, cosine, and tangent to get your components, add your components, and then find your resultant vector, then you can work your way through it. I know it's a little bit challenging, but think really hard about it. And then don't forget to text me and ask me. But here, it says you have a 230 mile an hour. This person is traveling due north, okay, at 230 miles an hour. So he's going straight this way. But there's a wind from the west blowing him. So he is going, let's draw his vector is 230, and the wind is blowing from the west at 45. Well, if you've ever tried to travel somewhere and you're going straight ahead and you've got a heavy wind, like in a boat, it's actually going to take you diagonally. So your actual path and speed are now going to be on that diagonal line. So you want to find out what this person's actual speed is going to be, which is going to be the magnitude and direction of that vector. So let's go ahead and find out what this, well, let's find out what this angle is. And so 230, 45, we have adjacent and we have opposite. So we could say the tan of theta is 45 over 230. So we punch in second tan, 45 over 230. And so we go second tan, 45 divided by 230. And you get 11.07. So he is actually going to be going 11 degrees east of north, right? Because this is north and this is east. So he's going to be going 11 degrees east of north. So now we find the magnitude simply by going 45 squared plus 230 squared equals the magnitude squared. And don't forget to get the square root. And you get 234. So 234 miles an hour, 11 degrees east of north is going to be his actual velocity. Okay, so draw the pictures. Draw the picture of the river with the current going this way, or draw the picture of somebody pulling a rope this way, somebody pulling a rope that way. Add your components to find out what the force added together is. There's a lot of things you can do with this. Thank you.